Good day everyone, welcome to the video tutorial for General Chemistry 1 Activity Sheet, Quarter 4, MELC 4, Week 2, Chemical Bonding. This is published by DepEd Region 6, Western Visayas. Let us start. Lewis proposed an explanation of bonding in molecular compounds. He reasoned out that an atom might acquire a noble gas electron configuration by sharing its valence electrons with other atoms. A chemical bond formed by sharing a pair of electrons is called a covalent bond, and the molecules formed are covalent molecules. Let's go to activity 1. This is the Lewis electron dot structure or the LEDs. The Lewis structure or electron dot formula of the molecule shows how the valence electrons are arranged among atoms and the molecule. The symbol of its element is used to represent the nucleus and all the inner electrons. The valence electrons are then shown as dots around the symbol. The element's group number indicates the number of dots to be placed on its symbol. For group 1A, 1 dot. For 2A, 2 dots. For 3A, 3 dots. For 4A, 4 dots. For 5A, 5 dots. For 6A, 6 dots. 7A, 7 dots. And 8A, 8 dots around the symbol of the atom. That means, class, that whatever the group number of the element, it shows also the valence electron. That is true for the group A elements in the periodic table. Okay, let's check it out in the periodic table. Okay, lithium, it's here. All these elements class mentioned above belongs in period 2. Okay, beryllium 2A, boron 3A, carbon 4A, nitrogen 5A, oxygen 6A, fluorine 7A, neon 8A. So the corresponding group also represents the valence electrons of the element. To write an element's Lewis dot symbol, you place dots to represent its valence electron one at a time around the element's chemical symbol. Up to 4 dots are placed above, below, left, and right of the symbol. It can also be arranged in another way. So, as long as the elements with 4 dots or fewer valence electrons have no more than 1 dot in its position. The next dots for elements with more than 4 valence electrons are again distributed one at a time, each paired with one of the first 4. For fluorine, the electron configuration is He. This is the core noble gas for abbreviated electron configuration. 2s2 to p5. So the valence electron is 7, and fluorine belongs to group 7 also in the periodic table. For example, the electron configuration shown as the normal electron configuration. So how do you know what is the valence electron? So just look for the highest coefficient. Okay, in this case, the highest coefficient is 2. And here, 2s2 to p5. So what you will do is add the electrons. 2 plus 5 is 7, which is equal to this one also. So how do we write it here? So the first dot is on top, the second is at the left of the symbol, the third is at the bottom of the symbol, and the fourth is at the right of the symbol. The remaining 3 electrons for fluorine will pair here on top and pair here at the left and pair here at the bottom. So the last final Lewis electron dot structure for fluorine is this one. So we have 2, 4, 6, 7. Looking at this class, we have paired non-bonding electron here. Paired non-bonding, and this is unpaired. But this has the tendency to pair because it has no pair. That is the one which has this tendency to share an electron with another atom. Okay, next, this is your first task. Refer to the periodic table and draw the Lewis dot symbol of its element below and write your answer on an answer sheet. Okay, so you have here 10. So we have magnesium, silicon, aluminum, chlorine, phosphorus, radon, potassium, bromine, krypton, and hydrogen. So look for these elements in the periodic table, and whatever the group will be the number of dots on the around the symbol of the element. Okay, let's go to activity number 2. The rules for writing Lewis structures are based on observations of thousands of molecules, and the most important requirement for the formation of a stable compound is that the atoms achieve noble gas electron configurations or the formation of complete octet. Octet means there are 8 electrons around the symbol of the atom. It comes from the prefix octa, which means 8. A systematic procedure is usually required to successfully write Lewis structure. Okay, so we have rules in writing the Lewis structure. Number 1. Determine the total valence electron in each atom. Use the periodic table to help you determine the valence electrons in each atom. So the first one here is chloric acid. So it consists of hydrogen, chlorine, and oxygen. Okay, look at in the periodic table. Okay, let's check it out. Hydrogen belongs to group 1A, so the valence is 1. Chlorine belongs to group 7A, so it will have 7 valence electron. And O belongs to 6A, so it will have 6 valence electrons. Let's go back. Now, we will follow this formula. So the number of valence electrons of each atom of element would be equal to the number of atoms times the valence electron. So this one number outside the parentheses would be the number of atoms. So hydrogen, how many hydrogen? 1. Chlorine, 1. Oxygen, 3. Hydrogen belongs to group 1A, so valence is 1. Cl belongs to group 7A, valence is 7. Oxygen belongs to 6A, valence is 6. So we multiply and add. So 1 times 1, 1, plus 1 times 7, 1 plus 7 is 8, plus 3 times 6, 18, is equal to 26. Let's go to the next. Phosphate ion and ammonium ions will have a different process. We'll discuss it later. Carbon dioxide. Okay, elements present here are carbon and oxygen. How many carbon? 1. How many oxygen? 2. Carbon belongs to group 4A. Please check in your periodic table. So valence is 4. Oxygen belongs to group 6A. So valence is 6. Multiply and add. 4 plus 12 is equal to 16. For ammonium or ammonia, Elements present are nitrogen and hydrogen. How many nitrogen? One. Hydrogen 3. Nitrogen belongs to group 5A, so valence is 5. And hydrogen group 1A, so valence is 1. Multiply and add. 6 plus 3 is equal to 8. For an ion, add the negative charge to the total number of valence electron. And ions are negative ions. So, phosphate ion. Elements present, P and O. P is equal to the number of atom, 1. Oxygen, 4. P belongs to group 5A, valence is 5. Oxygen belongs to group 6A, valence is 6. So add, multiply, and add also the charge. 5 plus 24 is equal to 29 plus 3 is equal to 32. For cation, subtract the positive charge to each electron. Cation as a positive ion. We have here ammonium ion. Elements present are nitrogen and hydrogen. Number of atoms for nitrogen, 1. Hydrogen, 4. Nitrogen belongs to group 5A, valence is 5. Hydrogen belongs to group 1A, valence is 1. And then subtract the charge. So 5 plus 4 is 9 minus 1 is 8. Okay, let's go to step 2. Find out the central atom or atoms. The atom with the highest number of covalency is considered as the central atom. Among the most common central atoms are boron, carbon, silicon, nitrogen, and sulfur. Hydrogen only forms one bond, so it is never a central atom because it has only one electron to share with another atom. Covalency of an atom is the number of electrons it shares with other atoms when forming chemical bonds. So the highest number will be your central atom. But there is another way in identifying the central atom. Okay? So another way of identifying the central atom is looking for the atom with fewer or lesser number. Okay? So, for example, for chloric acid, the lesser or fewer atoms here would be hydrogen and chlorine. But remember, hydrogen will not become a central atom because of only one electron to share. Okay, so it would be likely chlorine. So if chlorine is our central atom, that means oxygen will be the atom that will be attached to it around the chlorine atom. So draw a tentative diagram for a molecular ion. Use electron pair for single bond linking each atom to its neighbor. Single bond is equal to one pair of electrons. So we have Cl as our central atom, and then we attach the 3 oxygen by a single bond, and we attach the hydrogen to oxygen with a single bond. The hydrogen can be attached to this oxygen or can be attached to this oxygen. Okay, next for phosphate, so central atom would be phosphorus because it has the lesser number. And then there are 4 oxygens, so we have 4 bonds around it, single bonds. Then attach O. Next, for ammonium ion, nitrogen will be the central atom. And then there are 4 hydrogens, so we need 4 bonds. Okay? The plus here is shows that ammonium is an ion. For carbon, carbon is fewer compared to oxygen, so carbon would be the central atom. So attach carbon to 2 oxygen on the side. The oxygen can be attached also here on top and the bottom. We usually have it symmetrical. Next, ammonia. So the central atom would be N. Then there are 3 hydrogens, so we attach the hydrogen using single bond around the central atom, which is nitrogen. Step number 4. Distribute the remaining valence electrons to the attached atoms first, and then to the central atom last. Okay. So for chloric acid, there are 26 electrons around it. So remember that they have to follow the octet rule. For oxygen, to follow the octet rule, we already have single bond here. So that is 2 atoms. So we need 6 more. So we put the pairs, 3 pairs of non-bonding. 1, 2, 3, 4, 5, 6. This is 2, so it becomes 8. The same with this atom. 2, 4, 6, 8. For this, we have already the 2 single bonds, so it's single bond, remember, it is a pair of electrons. So 2, 4, 6, 8. So this is this also follows the octet rule. Hydrogen here is already stable with 2 valence electron, okay, because hydrogen is near helium, and helium has only 2 electrons. Helium is the nearest noble gas to hydrogen. So we have the bonding electron pairs is equal to 4. The single bonds, okay, bonding. That means these are already bonded, so it forms a single bond. A pair form a single bond. So 1, 2, 3, 4, okay. Non-bonding electron pairs or non-bonding pairs. 1, 2, 3, 4, 5, 6, 7, 8. Okay. The lone pair is 2. Lone pair or pairs is always attached to the central atom. So when a non-bonding pair of electron is attached to the central atom, it is called lone pair. Okay, so this is times 2 because it is pair. This is 8 times 2, 16. 8 and 16 is 24 plus 2, 26. So the total is 26. For phosphate ion, 32. So here again, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. And bonding, that is non-bonding electron pairs. That means there's nothing that is bonded to it. That is why it is non-bonding. So there are 12. And the bonding electron pairs, that means it is bonded and it is now a single bond here. 1, 2, 3, 4. Okay, there are 4. So times 2, 8, times 2, 24. Total would be what? 32. For ammonia, so N will follow, okay, the octet rule. This is 2, 4, 6, 8. So it follows the octet rule. For hydrogen, it has 2. Each of them has 2. Okay, so bonding electron pairs, we have 4 times 2 is 8. Okay, total is 8. Non-bonding electron pair, 0. For carbon dioxide, we have here, carbon does not follow because this is only 2 and 4. We will have a rule for that later. Okay, we will discuss that later. Ammonia. So nitrogen will have here 2, 4, 6 plus this 2, 8. So bonding electron pairs, we have 3, this single bond. And the lone pair, which is this on top, is also 1. So times 2. This would be 6 plus 2 here is 8. When we say pair, that means you have to multiply the number by 2 to make the number of electrons. Number 5. Check if the octet rule is followed by counting the number of bonds between atoms and lone pairs in the central atom and non-bonding pairs around the terminal atoms. Terminal atoms are the atoms attached to the central atom, except for hydrogen, which obeys the duet rule. Okay, we already discussed that. Now, here, carbon does not follow the octet rule. So, if this happens, electrons are moved between the atoms. In here, it is moved between carbon and oxygen atoms to follow the octet rule. Well, check it out here. Okay? If there are inadequate electrons to complete the octet, move one or more electron pair from an outer atom to form double or triple bond with the central atom. That will happen with carbon. So, remember we have 6 here. So, it was moved here. The 2 was moved here. So, we have double bond. So, this double bond, this is 2, 4, 6, 8. 2, 4, 6, 8. So oxygen follows the octet rule. How about carbon? 2, 4, 6, 8. Now, it follows the octet rule. Carbon follows the octet rule. It has 4 bonding pairs. 4 bonding pairs times 2, 8 electrons. So, note, for ions, enclose them with a bracket and indicate the net change. So for phosphate, net charge, indicate the net charge. So for phosphate, enclose it in brackets and then put the -3 outside. The same with ammonium, put it in a bracket or between inside brackets, and then put the charge +1. Plus is already understood as +1. Directions. This is your task number 2. Draw the Lewis structure of the following compounds. Write your answer on your answer sheet. We have only 5. Do not make a lot of tables anymore. It was only used to explain. Just use this last table, okay? So that means when you pass, there is only one table, but you will follow this arrangement now for the table that you will pass. This last table. So you have the formula, the valence electron of each atom or element, the total valence electrons, the tentative structure, and the final Lewis structure, okay? Activity 3. Exceptions to the octet rule. The octet rule fails in many situations involving covalent bonding. These 3 main types on the exceptions to the octet rule are discussed below. Molecules with odd number of electrons. The number of valence electrons is even in vast majority of molecules and complete pairing of electrons occurs. However, the number of valence electron is odd in a few molecules such as ClO2, NO, and NO2. Odd electron species are usually very reactive and consequently short-lived. Number 2. Molecules in which an atom has less than an octet, like beryllium and boron atoms with fewer than 4 electrons. It forms molecule with less than 8 electrons around each atom, such as BaH2 and BH3. Third, molecules in which an atom has more than octet. Definite atoms like phosphorus, sulfur, and xenon form molecules with more than 8 electrons around them. Example, XeF4, PCl5, and SF6. Okay, Then you have your third task. Okay? Directions. Drew the Lewis structures of the following molecules with less than and more than an octet. Write your answer on your answer sheet. Okay? So in this task, just write the structure. There's no need to follow the table. Okay? So the last part here is reflection. Complete the statements below. I understand. I don't understand. I need more information about. I hope you learned something new from this lesson. And if you had, please like and subscribe. If you already subscribe, it is greatly appreciated. Thank you so much. God bless and stay safe.